Hello and welcome. Today we're going to be examining crosstabs and chi-square tests to kind of examine what they are, how they work, and how to run them. So we're going to be using SPSS, Statistical Package for the Social Sciences. We're going to be using version 23, but once again, this should be backwards compatible. Most of these commands will go for many versions of SPSS backwards and hopefully into the future. Keep in mind as well, we're going to be using the federal sentencing data set for 2006. It's a small sample, and also today what we're going to be doing is using an even smaller sample from that. Once again, with the larger sample size you get, the easier it is to obtain statistical significance. So to make it competitive today, we're actually only going to pull 300 cases out of the 72,000 potential cases that are there. So what I've done is I put a little filter in here that is only limiting our analysis to 300 cases. Today what we're going to be examining are three different variables for kind of an experiment here. We're going to be looking at gender, we're going to be looking at race, and we're also going to be looking at, did the individual receive probation or some type of jail or prison sentence? So once again, the three variables we'll be running are, let's take a quick examination of the frequencies and we'll reset this. We will be looking at race. It's a dichotomization of race, so white and non-white individuals. Once again, not a great operationalization of this or recode, but for our purposes, using just dichotomous variables, it helps a lot. We're also going to take over sex as well. This is going to be just division between men and women, males and females. And we're also, beforehand, we looked at months in prison, but in order to look at the categorical nature of it, we've created a new variable called probation. And this is simply recode of months in prison. So individuals who receive 0 months as their sentence were given probation of some type or some type of released sentence, shock, incarceration, something of that nature, or receive some type of sentence. So 1 or over months is coded as a 1 in here. So it's basically, did the person receive some type of jail or prison sentence? If they didn't, they're coded as a 0 and they're on probation. And if they did, they're coded as a 1. So what we can do is we can run these very quickly, run some basic statistics. Let's just get means for each one of them so we know what percentage of our cases fall into what. So we can see right in here within race, we have 82 white defendants and 205 non-white defendants, so about a 27-68 split on there, with 13 individuals missing. Once again, it's a random sample, so we will have some missing cases. Within gender, 254 individuals are male, about 84%, and 42 are female, with about 14%, about 4 cases missing on gender. And did the individual receive probation? So 60 individuals received probation, so they had a sentence of 0 months, whereas 238 individuals received a jail or prison sentence, about that rest of 80% almost, with 2 cases being missing. So let's go ahead and run our first crosstab. In order to run a crosstab, we would go to Analyze, drop down to Descriptive Statistics, and go all the way down to Crosstabs. When we pull this up, we'll get our familiar rows and columns, so we can pull over the variables that we want to basically cross-reference with one another. So we can pull gender over first, grab monsex, I'm just going to toss it into the rows, and we will grab probation because we want to examine what percentage of individuals, or how many people were on probation, how many were on who receive some type of sentence, essentially, from here. So we can also get the cells too. I'm going to request the rows, just so we're calculating based on those rows. And let's just run this really quickly and take a look. So we can see for males, 14% received probation, where for women, 47% received probation. And within men, 85% received jail, while only 52% of women received a jail sentence. So I'm going to go ahead and close this out, and let's go back in. I want to rerun that crosstab. What I'm going to do, though, since we already know those percentages, just kind of make it nice and clean, I'm going to go ahead and just ask that it doesn't give me those percentages for right now, or we can leave them in. Let's leave them in. That's fine. But the other thing, the new thing I want to ask for this time is I'm going to go into the statistics button, click on it, and we're going to ask for chi-square, because the question becomes, did you see that huge difference between men and women on the likelihood within that sample of 300 individuals of getting probation or parole based on gender? My question is this a statistically significant finding? Just within these 300 people, this is all we have. Can we generalize that relationship back to the entire population of individuals within our sample? or within our population. So I'm going to ask for chi-square, and this is the statistic that will allow us to make that conclusion. So we just go ahead and check the box and click continue, and we can run this just like this. So when we click OK, we're going to get, once again, the same information we got last time. 14% of men probation, 85% jail, with women 47% probation, 52% jail or prison. And we're going to come down here to this statistic. There's a variety of other statistics, so if you're using one of the other tests, you would be able to look up that value. However, we're going to use Pearson's chi-square. The value is 24 with 1 degree of freedom. The key thing we want to look for is this asymptotic significance. So this is basically going to tell us if our finding is statistically significant, meaning that we can generalize it. Is the magnitude of the relationship large enough in comparison to how many cases we're examining, right? Larger the sample size, more likely to hit statistical significance. The larger the effect size, or the difference between the two, the more likely to see statistical significance. So do we have a big enough difference between the two groups compared to how many individuals we have in our sample? And in this case, yes, we do. So there's a very, very small chance that this doesn't extend back. Once again, the typical decision point on significance testing is 0.05, kind of that basic default. That will adjust based on your question, but for right now, we're just going to use the 0.05, and we can see our significance is less than that. We're 0.000, so this is some very extremely small number. It's being rounded to 0.00, but it is a non-zero amount. So because this is under 0.05, in that situation, we can say, yes, in fact, the relationship, the difference between men and women can be generalized back to the entire population. So this difference that we find between men and women, more specifically, men being more likely to receive jail or prison sentences compared to women, is something we can extend back to the entire population. Let's get another example here and take a look at it. Let's go ahead and do a comparison, crosstab. But instead of using gender, let's pull over that dichotomous race. Now, once again, this variable is coded as basically whites and non-whites. So it's a very crude, very crass coding of race. Not typically one you would want to use unless there's some either theoretical reason behind this or some type of data limitation. But we're going to run with this just to keep it nice and clean with dichotomous variables. For right now, let's we can go ahead and we know what we're doing. Let's go ahead and leave that chi-square in there, and we want the rows to tell us the percentages based on race. And let's go ahead and run that. And what we find here is that for white defendants, 24% receive probation, whereas non-white defendants, 15% receive probation. So there is a difference, but this difference isn't as stark as it was there for gender. So the question becomes, based on the fact we only have 300 cases, and actually in this situation, 285 is 15 cases are excluded because they're missing data either on race or on the probation variable. So with 285 cases, the question becomes, do we have a big enough difference for this sample size to be able to extend this relationship back to the entire population? So we go back down to Pearson's chi-square. This is the statistic that should allow us to make this conclusion. We have a value of 3.5 with 1 degree of freedom, and the statistical significance is 0.059. Now in this situation, compared to the gender model we just ran, we actually find that our statistical significance is above 0.05. Because of this, because we haven't fallen under that value, we're over 0.05, we actually cannot conclude that this is a large enough difference based on our sample size to extend back to the population. So we would, in this situation, actually conclude that that's not a large enough difference to say that whites and non-whites are being treated differently based on probation and jail prison decisions to extend that decision back to the population. And once again, this still means that we see about a 9% difference between the two. However, it's not enough of a difference between the two compared to the sample size to be able to extend this back to the entire population. Now, had we had the same difference, the same percentage difference with perhaps double the sample size, so if we had about 500 individuals, then we likely might see this drop below the 0.05 threshold. However, in this circumstance, in this case, we cannot say that there's a statistical relationship between defendant's race and the probation jail decision. So let's examine one other thing. I want to address the question as, how do we control for a third variable? So for example, let's say we are actually really interested in the gender question. That is the real key hypothesis that we have. So we're going to go back and we're going to put the mon-sex variable in to use gender. We're going to run it again just to make sure, yep, lo and behold, it's exactly what we had beforehand. But let's say we want to be able to address someone if they turn around and say, well, is it really gender that's driving this relationship, the difference between gender and then the type of sentence they received, or is it really that some other variable's functioning? In this case, let's use race because we've already run it. So what we can do is we can go ahead and we can actually throw in a third variable. So we're going to go right back to our crosstabs, bring it up, but in this box down here, we can actually put another variable in, and what it's going to do, it's going to divide the gender versus probation relationship into one box for whites and one box for non-whites, so based on the categories for our race variable. Now once again, you could do this for variables that have more than just two categories. You could do it for a larger section. However, I'm just doing it for simplicity purposes using dichotomous variables, but you could use larger. Keep in mind though, if you really start getting a lot of categories in there, it gets very confusing. So you want to try and be thinking about kind of keeping your models parsimonious and simple, unless your theory is going to dictate otherwise. So once again, let's get percentages by row, and let's make sure we got statistics for chi-square. And let's go ahead and run this. When we click on this, once again, we're going to get a lot more information here. We see we have 283 cases, so 17 are being kicked out because it's missing data either on gender, race, or on the sentencing variable. So when we look here, we can kind of see that there's a difference within the relationship. So this is looking only at white defendants here, this is looking at non-white defendants here, and this is looking at everything all together. So we can see the difference when we're examining then males and females. In the whole data set with all 283 individuals, we see 12% of males are receiving probation and 46% of females are receiving probation. However, when we examine non-white defendants, we're finding that 10% and 45% is the category. So not a huge change from these. And then when we examine white defendants, we find that 17% of men receive probation and 47% of women seem to receive probation. So we can kind of see a slight change. The white males in comparison to the females, there's a difference here. The question becomes, does gender really play a major role there? And we can slide down here and examine basically these two tests between the two groups. So when we're just examining the white defendants, does gender make a difference? And in this case, yep, 6.8, 1 degree of freedom gives us 0.009. This is below 0.05. And for non-white defendants, we have a value of 19 for our chi-square, once again 1 degree of freedom, and 0.000. So this tells us that yes, even when we subdivide individuals based on gender and just examine, in this case, whites, and just examine non-whites, so when we split them, we still find that there's statistical relationship between the two. However, had we found that this did not, so for example, had white defendants been over 0.05, we would find that gender only plays a relationship in these non-white situations. When it comes to white situations with white defendants, that it wouldn't play a statistically significant relationship. So that's where you would examine to control for a third variable. I hope this has been helpful. It gives you a little bit more familiarity with, once again, running crosstabs and now introducing this chi-square statistic, which will allow you to generalize your findings back to that entire population and make a conclusion as to, is your relationship strong enough based on how many cases you examine to extend the relationship back to make a conclusion about the entire population, in this case, of all defendants that were sentenced in the federal system in 2006. I hope this has been helpful. Good luck, and don't hesitate to contact me if you have any questions.